Hello, everybody. I see that the doors are just opening and we still got people rolling into the auditorium. So this first minute, I tend to speak very slowly as everybody rushes in and finds their seats. I like to imagine that it's like a Walmart on Black Friday or something, except that everybody gets a front row seat. My name is Adrian Goins, and I am the Director of Community at Rancher. You are at a masterclass on how to automate privacy protections, PCI compliance, and vulnerability management for Kubernetes. If that's not where you meant to be, then just hang out anyway, because it's a pretty cool topic, and it's certainly a mouthful of a title, and we wouldn't want you to miss out. So that's me on the left, Director of Community. I live in Chile. I work at Rancher, and I am joined today by people who are far more interesting than me. I have Henrik Rosendahl and Glenn Kusaka from NeuVector. Are you guys both here?
Good morning,
Yep,
Adrian.
great to be here.
Yay! Awesome, awesome. It's super great to have you. These two guys, I've been going back and forth with them on their slides for the last week, and I am super excited for the volume of information that they are about to drop on you. This is a really unique and specific subject for Kubernetes, and they're going to blow you away. But before I let them take the mic, there's a little bit of housekeeping that I have to do. This is a Rancher Masterclass series. This is our advanced training class. It's a little bit different from the meetups or the basic training or the webinars or the rodeos or all the other events that we do. This is super technical specific information that it's intended to give you actionable data that you can take out of the masterclass and immediately go apply. Now, granted, today we're talking about PCI compliance, and that's a bit of a niche subject, but the security parameters around PCI compliance are things that you can apply to any Kubernetes cluster. I mean, who doesn't need more security? But because this is an interactive session to the extent that we can interact with one another through the little chat console, we want you to ask questions. If you look at the GoToWebinar tab menu thingy that's attached to the right hand or the left hand side of your screen, you'll see that there's a questions section. If you just, when you think of a question, ask it there. We will pause at various points throughout the presentation to answer those questions live. Or in some cases, since we have multiple people here, we might answer them just directly in chat. If you ask a question that you specifically don't want us to answer publicly or that you don't want us to answer out loud, just say so in your question. Put like private in parentheses or something, and we'll just answer you back privately for that. The only thing that I ask is that because we have a lot of information to cover today, please try to keep your questions on topic, specific to the information that you're learning. If you have Rancher general questions or Kubernetes general questions, you'll see in a couple of slides, there's other places where you can ask those questions. And if you ask them here and we can't fit them in, certainly if we have enough time, we'll just talk about whatever, but I don't think we're gonna have enough time. So if we don't answer your question, I'm sorry. We will do our best to stay until all questions are answered. And please don't be offended if we reply to you and say, hey, let's take that offline. One of the first questions we get is this session being recorded? In fact, even though I have a slide here that says that this session is being recorded, somebody's going to join the webinar in 2 minutes and they're going to be like, is this session being recorded? Yes, this session is being recorded. At the end of the session, not immediately at the end of the session, but GoToWebinar processes the video. It actually comes to me. I do some post-processing and I upload it to YouTube. And you will get an email, generally about 24 hours, that has a link to the video and a link to where you can also view the slides. But in the meantime, we encourage you to join the conversation on the Rancher users Slack. If you don't already have access to it, just go to slack.rancher.io and enter your information there, and you will get an invite that allows you to join. I mean, anybody can join, just go get an invite. Once you're there, join the masterclass channel, and that's a place for all of you to talk amongst each other, not just in this class, but in any future situation where you want to come back and ask questions and stuff. The Rancher user Slack is for the community. It's for all of you to join together and help one another out and share your experiences and share your challenges so that together all of us can become stronger. As I said at the beginning, this is our advanced online training, but if you're relatively new to Kubernetes, we also run a weekly intro to Kubernetes and Rancher. I often run that. The next one is happening this Thursday, and you can sign up for that. That's free. You can take as many of them as you want. In 90 minutes in that class, you're going to learn basics of Kubernetes and basics of Rancher, enough that you can go out and start to get your feet wet with Kubernetes. Though I'm betting if you're in this class on PCI compliance in a Kubernetes cluster, you probably don't need the basic training. But come join anyway, because you might learn something. We also run masterclasses, these classes, every week when we have partners or customers or Rancher employees who are able to present new and interesting information. We try to run them every single week. Occasionally we skip one, but there you'll find really specific stuff. And if you have any ideas for masterclasses on specific topics that you might like to see, reach out to us and let us know those ideas. We'll, do some processing and discussion internally, and maybe we can get that out in a masterclass for you. There's always somebody who joins the webinar who isn't really familiar with Rancher. So if you'll give me just a couple of more minutes, I want to give you a quick overview of who we are and what we do. Rancher is a company that makes open source software around Kubernetes. Our flagship product is a Kubernetes management platform called Rancher. It's not really a platform, but it's a solution that allows you to deploy and manage Kubernetes clusters anywhere in the world. We have two Kubernetes distributions, RKE and K3S. RKE is a full data center certified, well, they're both CNCF certified, but RKE is designed to run in data centers. K3S is super lightweight and designed to run in edge environments, but it also runs great in data centers and cloud environments and anywhere else. We have a number of other projects. We have Rio, which is an application deployment engine for Kubernetes, K3OS, which is in development, and that's an operating system built around K3S. We just announced Fleet, which is a management solution designed to scale up to thousands and eventually millions of Kubernetes clusters, allowing you to manage them as a single entity. We also have Longhorn, which has been in beta for a while and is coming up pretty quick on a GA release. That is open source distributed block storage for Kubernetes clusters. And that's actually a CNCF sandbox project. We also have Submariner, which does a really cool mesh, a really cool VPN tunnel between Kubernetes clusters, allowing you to have resources in multiple clusters that can communicate with one another without traversing the internet through external means, although technically it still traverses the internet just through a nice tunnel. Everything that we do is free and open source, 100% free, 100% open source. Somebody just posted a question in the question that caught my attention for a second, but he says it's fine. That's good. I love questions that resolve themselves. Everything that you ever see us do at Rancher, I was going to say everything you see today, but today you're actually going to see some of NeuVector stuff. But the Rancher components of what you see, you can go and you can do yourself. Everything is out there. We build our products and projects on a methodology, an approach for what we have seen works to get Kubernetes up and running at scale. And that has some tiers or pillars. They're not really pillars because they're kind of laying on their side. But in the base pillar, if it's laying on its side, you have CNCF certified Kubernetes distributions. That's going to be the core of your solution. Now, Rancher supports any certified Kubernetes distribution. We also have two of our own. As I said, we have full support for infrastructure providers in the cloud, which we can then deploy Kubernetes into for you. And we also support all of the hosted Kubernetes solutions. Here we've got EKS, AKS, GKE, but there's others that we support as well. Once you have that base established, then there's centralized management on top of it. Rancher is the industry's most widely adopted Kubernetes management platform. I'm going to keep telling you, it's open source. People, they'll see what they can do with it, and they're like, well, how much does this cost? It's free. It's totally free. It's not open core. It's not limited. It's just there. It has more than 30,000 deployments, more than 100 million downloads. It enables production quality Kubernetes everywhere by delivering on the key requirements for Kubernetes management. And that's consistent cluster operations. It gives you simple, consistent cluster operations that include provisioning, version management, visibility and diagnostics, monitoring and alerting, and centralized auditing. It gives you security policy and user management so that you can automate processes and apply a consistent set of user access and security policies to all of your clusters, no matter where they're running. And then shared tools and services. We have a rich ecosystem catalog of services for building, deploying, and scaling containerized applications that includes app packaging, CI/CD, logging, monitoring, and service mesh. With this approach to solving Kubernetes challenges, you will find success. And we partner with other leaders in the community to help solidify everything that you do. We can't do it all, they can't do it all, but together, well, what is it? Together we're stronger, together we're better, together we're together. And I think that's a really important thing to remember in this day and age. And that's why we're here with NeuVector. So Henrik, I believe you are up next. Are you ready?
Yep, I am ready, Adrian. Thank you for the introduction.
All right. Take it
All
away.
right.
Let's see. See what you got.
Yeah. Let me just grab the presentation. Can you pass me the presenter right?
Oh, I thought you could just steal it from me. Okay, I will. This is my favorite part. This is the part where I get to scroll through the attendee list and try to find. Oh,
Exactly.
looks like you took it.
I just did that. Yeah.
Glenn took it. It's like football, except
Yeah,
if you
exactly.
could
Passing it back and forth, right?
steal the ball from one another, right?
Alrighty, let me just go into full screen mode here. Can you guys see my screen?
We can see your screen. Yep, waiting for you to change over to just the slides.
Okie doke. Awesome. So thank you guys for joining us this morning. My name is Henrik Rosendale. I'm here with Glenn Kosaka from the NeuVector team. The quick intro to NeuVector is that we are sort of an end-to-end lifecycle security platform for Kubernetes, and the vast majority of our customers are using it for PCI compliance or some other, heavily compliant or regulatory means. So this is kind of what we live and breathe every day, and we're excited to give you a sort of a lowdown on why is it so hard to make Kubernetes PCI compliant, and what do you need to do sort of very practically to overcome some of these challenges. So with that, let me just go through the agenda here. I'm expecting this to be somewhere between a 45 to an hour long presentation. We will do 3 demos along the way. So we're going to break up the death by PowerPoint by some live demos. And so first of all, I'm going to give you guys an overview of the PCI DSS compliance requirements, what you need to do to make it compliant in a Kubernetes environment, and actually show you, or Glenn will show you some network security policies and security measures. Then we're going to talk about building security into your pipeline, and why is it important to build security into the very beginning of the pipeline so it flows through from there. We're also going to talk about virtual patching. If you haven't heard about this concept, it's super exciting, and so I'm going to not steal Glenn's thunder, but leave it at that. Glenn's going to do an end-to-end vulnerability management demo. And then finally, we're going to show you some exciting new concepts called security as code or security as YAML, depending on what sort of lingo you want to speak. What is it? How is it deployed? And why is this a great way to have a DevOps team and a security team cooperate on a sort of a security posture? At the end, we're going to do our very best, as Adrian said, to answer everybody's question along the way. With that, so let's just talk about PCI DSS compliance and what do you need to do. I mean, first of all, it's there to protect cardholder data. In fact, that's the cardholder data industry, right, that has set these sort of guidelines. And it has some very specific requirements that are really hard to do in Kubernetes. And my next slide will talk about why these things are so hard. But first, you got to build and maintain a secure network, right? And you can do that in Kubernetes with network policy. You can use service mesh like, Istio or Linkerd or similar. So you've got to have a way to secure and sort of segregate the network. You can, of course, use NeuVector as well, and we'll show you some of that. But Glenn will also demo, how you actually do a network policy directly with sort of core Kubernetes. You also have to, monitor and test your network, and provide visibility into the network. And that's really hard because it's such an unruly environment. And so for open source tools, you can use Weave Scope, and there are other tools that will help you provide some visibility into the network. As for vulnerability management program, as it's called in the PSS program or standard, you can use any vulnerability management tool really. Claire, if you want to go open source, we're going to show integration into JFrog, X-Ray. I mean, there's a dime a dozen out there, right? And so It is important that you embed that vulnerability management all the way in the beginning, all the way on the left side of the pipeline, and then it flows through all the way to production. And that's where a lot of these scanners fall short. They will do a good job in the sort of the left side in the pipeline, but then they don't continuously do vulnerability management involved in the scanning while in production. And so Glenn is actually gonna show that from soup to nuts. Implement strong access control, right? So you can use Rancher, Kubernetes, sort of RBAC is actually a really good way of providing sort of role-based access control and making sure that people have access to certain namespaces, but not sort of like broad admin access. And then finally, you've got to maintain an information security policy and translate it into a sort of a Kubernetes world. That means locking and change control. You could, for instance, use LogDNA, or you can use OPA as a open policy agent for high-level security policy. You got to consider these tools as a part of providing an overall PCI framework. So why is it so hard with Kubernetes and containers? As many of you probably know, there is of course an east-west traffic explosion, right? And so you're going from limiting a few network connections coming in and out of a VM or in other environments to hundreds, if not thousands, of east-west connections between all the containers, and it could just get sort of elevated if you're using a service mesh on top of that. So you got to deal with a massive amount of network traffic all of a sudden. The next part of this is, of course, the ephemeral nature of containers, right? And so an average lifespan of a container is probably a couple of minutes, right? And so if a container is compromised and you don't have packet capture, or you haven't created sort of a sandbox version of this, you have no way of actually knowing what happened. And that's a part of the whole PCI compliance, is being able to go down and do the forensics afterwards to figure out what went wrong and then improve from there. And so that is really, really hard to do. Of course, you got like rapid changes in DevOps, right? Rapid updates, and it could be hourly, it could even be several times an hour. This is a really rapid, changing environment, and so exactly what version was compromised, what happened, where did it leak, who's responsible. All of that is just really hard without some good logging and change control. Of course, there's extensive use of open source libraries. I mean, I have yet to see a container that doesn't have some open source in there, and with that, you are subject to potential malware or attacks, right? And so you're pulling code, you're pulling library from somewhere else, and unless there is a specific vulnerability attached to that library, you don't actually know what's in there necessarily. And so that, of course, elevates the risk here. The low visibility into the network, of course, it goes along with the east-west traffic explosion. It is hard to control, in particular when you're talking, dozens of nodes and multiple clusters and potentially even multi-cloud. And so trying to lock all the network connections down as required by PCI is difficult, and it's difficult to maintain over time. You might be able to do that on day one, but day two and beyond, it's actually a sort of a big task. And then finally, Kubernetes is an evolving platform, right? It's a relatively new platform. It's requiring new processes. It's a new technology. There are new tools. There are new teams. There are new clouds. And with all that newness comes the risk of missing something. Missing configuration or password, leaving ports open, so on and so forth. And that's just the nature of the beast. So what are your options out of the gate to run a PCI compliant environment with Kubernetes? The first option is by far the most sort of conservative option, which is don't do anything. Just keep all your compliant data, your cardholder data in a traditional environment. and don't handle anything with Kubernetes that has anything to do with cardholder data, right? That's the very conservative approach here. The second approach is if you want to have cardholder data in your Kubernetes application, you can run that in a separate Kubernetes cluster, and you can use your existing firewalls to guard those data, right? That is one approach. It basically means that you have to maintain a separate cluster just for handling the cardholder data. And then, the third approach is, of course, what NeuVector is advocating, that you should create a Kubernetes native firewall and enforce the segmentation and the whitelisting within the cluster. It makes so much more sense to have the contextual awareness of what the application is doing in the cluster, and then using a firewall that is native to Kubernetes to manage all of that. And Glenn will be able to show you a sort of a multitude of different approaches here in the demo coming up in a couple of minutes. So let's talk about first things first. You must build and maintain a secure Kubernetes network. This is what the standard body is advocating. On the network side, again, you must create a real-time network diagram so you understand what's going on, where are the connections being made to, from what containers to what containers, inbound and outbound. And that's the next part here. You have to restrict all north-south or inbound, outbound traffic, which means that you have to close every external and internal or external connection unless otherwise whitelisted. And that's the third bullet point here. All unauthorized connections must be restricted, which means you have to create a fully comprehensive whitelisting policy that will only allow predefined connections to be made, both east-west as well as north-south. And then you have to create the internal segmentation zones with the cardholder data. As I alluded to earlier, you could either do that in a separate cluster, or you can simply create a zone within a cluster, and then guard that, for instance, with network segregation, as well as implement DLP. And DLP, for you guys that don't know what that is, it's data leakage prevention. You can see that over on my right-hand side. It's a way for the firewall to look for data such as social security numbers, of course, credit card numbers, birthdays, etc. And if it sees any unauthorized data outside of the safety zone, then it will literally shut down the network connection, so data is not leaking or escaping out of those zones. So what else do you need to do other than the network measures? You need to, of course, create end-to-end vulnerability management from the very beginning of the pipeline, but also through production, right? So that's important. We'll show that in a minute or two. You of course need to keep up with patches on Patch Tuesday, and make sure that you're running on the latest Kubernetes version would be a really good idea. And obviously keeping a lock on that. Virtual patching, so I'll allude to that, but Glenn is going to show that in his second demo. But essentially, virtual patching is you're trying to compensate for a high vulnerability found in a container that doesn't necessarily have a patch to it, and you're compensating with security policies either around the whole environment or just around that container to essentially make up for the security differences here. And then finally, you have to do configuration checks and CIS benchmarks. It goes without saying that if you're rolling out a massive environment, there are thousands of configuration checks that need to be safeguarded there. And so, in fact, most of the hacker attacks we see right now on Kubernetes are caused by just like sloppy configuration, and they can be mitigated with CIS benchmarks and other configuration checks. So let's just talk about scanning versus network inspection, right? So to me, scanning is sort of looking in the rearview mirror here, as you can tell from my front screen. It is a state or at a point in time where you're looking at vulnerabilities and you're doing your best to weed them out up front, but there are a high number of vulnerable libraries where there are no CVEs and scanners will not find anything. And so the traffic inspection, the network traffic segregation, and then DLP is sort of like the safety measures. If you don't find a vulnerability in the pipeline, then you should definitely be able to minimize the risk while you're in production, putting the right sort of network safety measures in place. And if you look at this slide here on the left hand side, you see the sort of the nature of a hacker attack is called a kill chain. And it actually has multiple sort of steps, all the way from recon, weaponization, to installation, command and control, and exfiltration of your data. And the vast majority of these hacker attacks have some network component to it, right? It's, at the very least, the data has to be exfiltrated to go somewhere to be valuable to somebody selling it on the dark web or something. And so that there will be a network connection for sure, but most of the attacks will also actually enter from the internet, from an unguarded port or something like that. So if you look on the right hand side, the table here, you will see that each and every of these known attacks will have a network component to it. There will also be a container specific, like it could be a process, or it could be like file system activity that is abnormal. And then on the host, again, it can be a process, or it could be privilege escalation or similar, that will alert you to something not being right. And so some of the open source tools that are out there, including Kubernetes itself, will do a good job of RBAC, for instance, as a role-based access control, secret management, POC management. Kubernetes does that. Kubernetes has a network policy where you can put up network segregation based on layer 3 and layer 4. Some customers opt to a service mesh, so be Istio or Linkerd to do service routing, but also do encryption of the network connections. But if you go and if you must have layer 7, like deep packet inspection, isolation, threat detection, packet capture, so on and so forth, you have to resort to third-party tools. NeuVector, of course, being one of them. And so with that, I'm going to stop talking, and I'm going to give the console to Glenn for the first demo of the day.
All right. Okay, so I'm showing my screen, so let me know if you're not seeing my screen. So I'll first describe the demo environment, and then for the first part, I'm just going to focus on the network segmentation aspects of security, as Henrik talked about for PCI. So this is a 3-node Rancher cluster using RKE. And on this cluster, we've deployed, you could see here, the NeuVector containers. The controller is our control plane. 3 pods have been deployed for HA reasons, but one of them is active at any point in time. The enforcer is really doing all the inspection and heavy lifting, and it's deployed as a daemon set. So you can see 1 per node, 3 pods deployed there. And then also the manager exposes the console interface, which is running here. So once that's all deployed, you can log into NeuVector, and you can see that we've discovered all the containers running in the infrastructure, and we're starting to see and display, help you visualize all the network connections. So typically this would be in a staging or test environment where you're going to run your test suite through your microservices application, just making sure you're not only verifying the application behavior, but you're also helping to populate the whitelist rules that Henrik talked about. And also you could see here there's information on every node, the rancher, the OS that's running, vulnerability scanning of those nodes, as well as all the containers that are running in the environment. So if I focus on, go to my terminal, and so in my demo namespace, I've got a few demo containers running, and so we'll take a look at those. The key ones that I'm going to be using today are this 3-tier stack. So I've got a little load balancer and Nginx talking to 3 Node.js pods, and that's talking to the Redis pod. And I've got another container here called the exploit container, which is running here on the left. It helps me run a few attacks that I'll run later. But if we,
Glenn, is it possible you could zoom your font in a little bit? Command plus a couple of times.
sure. Maybe I can even just.
I'm gonna have to resize your tmux there.
Is that better?
It's better for me, yeah. Thank you.
Okay. All right, so let's take a quick look at my Nginx deployment. So it's a very simple deployment. You can see listening on port 80, and then my Node.js pods, you could see are listening. There's a service to receive connections on port 8888. So as Henrik mentioned, there are many tools that you can use to cobble together what you need to do to segment traffic, as well as to do all of the PCI compliance steps. Of course, one of those which is built into Kubernetes is network policy. And of course, you do need to be using a network plugin that supports enforcement of network policy. So we could build a simple network policy that really restricts or only allows Nginx to talk to Node on port 8888. And so that's what I have here. You can see it's a very simple policy here in the demo namespace. Node can talk to Nginx on port 8888. And so what we're going to do first before we implement that policy is we're going to do, a simulation of an east-west attack. So this is where, for example, let's say one of my Node.js pods got hacked, and the hacker is trying to connect laterally to another Node.js pod to expand the blast radius of the attack. And as we saw, really that type of connection should not be allowed. It's Nginx talking to Node, which is then talking to Redis. So if I do that, you could see here that I get a response, read 47 times. So what I'm going to do is, let me implement that network policy. I'm going to do a create or apply and set up that ingress. Okay, so just like that, I've created a segmentation rule. And really only, as we saw in the YAML file, it defines the ingress to the Node.js pod is only going to be allowed from the Nginx pod. So if there's a Node.js pod getting an ingress from any other pod, it doesn't matter what namespace it's in, that should not be allowed. So if I go and I do my node violation again, you can see that nothing happens. Kubernetes is doing its job. So you can see how you could build a bunch of network policies to govern all of the connections between all your container services. By the way, you can also govern the ingress from outside the cluster, as well as if this Node.js pod needs to reach outside of the cluster to an API service, you can also create an egress policy to an IP address or an IP address subnet. So, but one of the issues with, trying to cobble together a lot of tools is the visibility, and as Henrik talked about, forensics, alerting, all of the things that not only are you required to do in a PCI environment, but you should be doing as a general security practice, right? So we should make sure that we're not just blocking connections, but that we're detecting them, we're logging them. If needed, we're also packet capturing those connections. Because we need that to investigate an attack in real time, because the attack is comprised of a kill chain. In addition to that, we need that for PCI purposes to save for forensic reasons. So I've removed that network policy, and I'm going to switch over to my NeuVector console and describe a little bit more about how a similar type of network policy or set of network rules can be implemented more easily and more PCI compliant. So as I talked about, NeuVector will automatically discover these connections, and we can see the connection coming from Nginx going into the Node.js pods and the rest. We can also see that the blue lines here have been created that auto-detect the protocol being used. It also sees the port being used, but as you'll see in a second, we're going to build layer 7 rules, which are based on application protocols, not on port, because they're more flexible. You can see that automatically a rule number 16 was created to whitelist that or segment that type of connection. And then similarly, you can also see here that this Redis connection was detected using the Redis protocol. Even though it's running on 6379, a rule 15 was created to whitelist that. So if we look into all of the container services that I've detected, and I look specifically at my Node.js one, I can look at the network rules, and I can see these rules were learned automatically. Node can talk to Redis over the Redis protocol, and Nginx can talk to Node over HTTP. There's also a DNS lookup that's allowed. Similarly, NeuVector is also going to look at the file activity and the process activity running in the container, and will automatically whitelist those. We'll talk a little bit more about that later, but we'll focus on the network rules for now. So now that I've reviewed these rules, I can switch the mode that these containers are running in from the discover mode into the monitor mode. And in the monitor mode, any violations of these rules right here, which basically means if there's a connection that's not on this list, it's going to allow it, but it's just going to alert you. So it's going to log that. So if I run that same node violation, I get a response here. And I can see for logging and alerting purposes, I can see that that shows up, and this could be sent to my SIM system. It can be logged forensically. We can start a packet capture on the offending container. So all of the required logging, forensics, and alerting is in place automatically. We can also see that if this was truly a CDE environment that I need to protect against attacks, I can also go in here and I can switch that. Oh, let me just unselect that one. And then let me switch this into the protect mode. Now in a protect mode, this is actually running as a layer 7 firewall. So if anything violates that rule, even if it's running on a different port, it's going to be blocked. So if I run that same violation again, you can see that nothing happens. And so I'm seeing the response here in the command line, the same thing that I would see with network policy, but when I go into notifications, I can see that we've detected that an attack is tried and that it was blocked. So this is the level of reporting that's really needed if you truly want to implement defense in depth. In addition to that, visually, you can see these this connection here and all of these rules as well. Now, I'm not going to get into too deep about a layer 7 versus layer 3. Suffice it to say that layer 7 is looking at application protocols. It's looking at the packets. It's doing deep packet inspection for not just looking for protocols, but it's also looking for network-based attacks. So I'll run a couple really quickly here to, let's see, let's do a ping death attack. So this is going to try to do a simple denial of service attack on one of the pods there. And we can go into NeuVector, refresh this, and we can see these network attacks start to show up. We can also run a a simulated SQL injection attack. It's actually a SQL login attack, just trying to hack into the SQL container. And we can see those show up here. Now, not only can you visualize these, but in the case of this SQL injection attack, we've turned on automatic packet capture. So you could see here that when I ran this a few days ago, that we automatically captured the packets, and you can download this as a PCAP file. You can store it in your forensic system, etc. Now, you can use TCP dump and try to figure out the pod name and the IP address of the pod. But as Henrik mentioned, things are happening so fast in a Kubernetes environment. To do that manually could be quite challenging. In addition to that, there is automated packet capture for network-based attacks that happens. For example, this ping death attack, we will automatically capture that packet and save that for you. That's a quick tour of some of the real-time network segmentation capabilities in Kubernetes and NeuVector. The added thing that Henrik talked about was being able to deep packet inspect for credit card data. As PCI requires you to protect that data, you may want to inspect your critical CDE environments to make sure that unencrypted credit card data is not leaking in or out of it. So you're able to define a credit card sensor here. We have it built in. Or if you have custom account numbers that you can match with a regular expression, you can add your own regular expression-based pattern matching to look into those packets and try to detect the sensitive data. Now, the way this works is, as Henrik talked about, you would define what your CDE environment is. So let's say my CDE environment, I'm going to define here as domain equals demo. So basically everything in my demo namespace is my CDE environment. Now what I can do is I can apply this credit card sensor, and I can set it to either alert or to block any credit card violations that we detect in the CDE environment. And by applying it to a certain environment, we're only going to inspect the packets that are entering or leaving the containers in this environment. So here we've got 9 containers running the environment. All the interpod traffic that we saw is not going to be inspected. It's really anything entering from the outside of this CDE environment will be inspected with the credit card detector, as well as anything leaving this environment will be inspected, and any credit cards detected will be blocked. Those connections will be blocked. All right, so I think that's a quick tour of some of the network segmentations and network activity. Henrik, why don't I turn it back? Yeah.
I just did.
Okay.
Just did. Okay. Let me know if you see my screen here. I should talk about building security into your pipeline. See it?
Yeah.
Okay, great, cool. So let's talk about how you build security into your pipeline and what the difference is between pipeline and production security, right? That's often sort of like an overlooked area. And then, as I mentioned earlier, Glenn is going to show virtual patching as an exciting new concept here. So let's talk about the pipeline here for a moment, and what are the top security issues for cloud native deployments, right? So first of all, as I mentioned earlier, you can have critical vulnerabilities in any stage of your pipeline, right? They can enter in at any stage, or you can think you have a clean image, and all of a sudden there's a new vulnerability being discovered, and you have to rescan and redo that image. If you do not put security measures into your pipeline, it will inevitably slow you down, right? There will be manual configurations, there will be manual scannings, a bunch of integration work that needs to happen manually. So you better do that sort of as a core part of the pipeline. I talked to this earlier as well. So misconfiguration of your registry, of Kubernetes itself, of course, your host and your containers is definitely an area that you need to monitor and to manage. With Kubernetes itself, you have a new attack surface, right? You've got Kubernetes as a sort of a new-ish platform, and therefore vulnerable to new CVEs. You've got the Docker runtime, you've got new tools, you've got new processes, you're running in new cloud environments. You gotta be aware of all these new attack surfaces. And then finally, most customers today that are not running sort of a PCI compliant environment have wholly inadequate production protection in place, right? And so there are just simply things that cannot be scanned for, right? You cannot scan for a zero-day attack. It is really hard to avoid insider attacks unless you have phishing solutions in place, et cetera, et cetera. And so here is an example of building security and vulnerability scanning into your pipeline. To your left, you got a sort of a classic Jenkins pipeline screenshot, and to the right, you got vulnerability scanning result and the layers in each image, right? So you can see here the bottom pipeline, the build was rejected by the vulnerability scan. We built some criteria in there saying you cannot have, for instance, any high priority vulnerabilities in a PCI compliant environment. That's a good rule to have. And so it will automatically fail that build. You have to go back in. We will notify the developers and what image is in question and fails the build, and you will have to go back in and basically redo that image. And so you of course have to sort of make sure that there is a fix to that vulnerability, and if there is not, this is where virtual patching comes into place. If you're forced to go into production with an image that have vulnerabilities, but there are no fixes for it, here is what you need to do from a policy, from a network policy, or even a sort of a broader security policy to mitigate that risk. And so on the runtime and production scanning side, of course there's a gating feature in Kubernetes called admission control, and it would be silly not to use that as the bridge between the dev and staging and production, right? You can set up a lot of really detailed and really nice criteria for when an image is allowed into production, and production can be different production clusters, such that you can have a PCI compliant cluster, and of course the criteria will be much higher than just sort of like the average cluster. You also have to automate your vulnerability scanning and compliance checks in runtime, which means that every time you update your CVE database, not only should you rescan your registry, you should also scan all the containers that are running in production or even in staging environment, right? And then so that's really, and when I say scanning, it's also CIS benchmark audits, as well as running sort of a risk report on a daily basis, so you can see if your posture is going up or going down. And so Glenn, do you want to take it from here and talk about virtual patching? I think I've teed it up.
Sure. happy to do that. First, let me grab the presenter. So we can do that. All right. All right. So virtual patching. This term actually is not a new term. And what it really represents is the ability to essentially prevent an exploit of a vulnerability, essentially patching it virtually without having to actually update the package library that's vulnerable. And companies like Trend Micro have been doing this on VMs for a long time. And there's various techniques for implementing virtual patching. And so the one we're going to talk about in a Kubernetes environment is really what you can see here is that each workload can be essentially bounded, and all of the behavior of the workload can be whitelisted. And that includes network connections, processes, and file access. And once we're able to bound that workload in terms of what is whitelisted and allowed, then there's no chance that a vulnerability that exists in that workload can be exploited without an unauthorized network connection occurring, or an unauthorized process starting, or some file activity starting. So in that way, we're able to virtually patch that vulnerability because, as we know, there's not always a patch for the vulnerabilities available immediately. Or the way some pipelines work, they're not quite as automated, so they can't patch that within hours, like the container vision or like Google can. Sometimes it may take a couple days to patch to get it through a new image build and through the pipeline and test and QA and all the way into production. More traditional pipelines may take a week to do that. So it gives you the breathing room to protect against those vulnerabilities. In addition to that, it will protect against embedded malware. Henrik talked about, if you're using open source, there's a lot of Docker containers that have been discovered to contain malware or phone home things in them. So if any of those try to start up, they're going to generate an unauthorized connection or process. Zero-day attacks, insider phishing attacks, those are all things that will be protected against. Now, before I go into the demo of the vulnerability, the management part, I noticed a few questions coming through here, and I'm wondering, Adrian, should we go through some of those, or should we wait until the end?
Oh, let's go through them, because the questions that I flagged for you guys they've been out there for a little while. There's only 3 of them.
Okay.
Robbie asks if there are any open source tools that can simulate attack scenarios, or hang on, I gotta expand this, or automate
The threat
the
simulation.
threat simulation.
Yeah. The little container that I was using to generate some SQL and some DDoS attacks, that's available on our Docker Hub. It's a little container that can be run in your cluster. But I'm not aware of other tools that can do this in a containerized environment, because you've got to discover the services running. You've got to, if you're going to attack directly a container, you've got to be able to get to the IP addresses of the pods. There are traditional pen test tools, of course, that can test web applications or infrastructures. So those can do some amount of testing from the outside, but nothing that that I've seen that can really do it from either within a cluster or outside into the services or containers running in a cluster. Part of it is also, for example, we ran a demo of an Apache Struts exploit that was used in the Equifax data breach. It's fairly complicated to set those up and to set up vulnerable environments so that you can test and do those types of test exploits. So, it's not something you can just run as a container.
Okay. John asks, if virtual patching is really detecting malicious behavior and not actually patching the vulnerable piece of code or
Yeah.
library or something.
Exactly, yeah. So that's why it's called virtual patching, because it's not actually patching the code. You know, that should be a integral part of your pipeline, as Henrik talked about. And at the beginning of your pipeline, if they're building a new rev of that container, and there's a fix available, there's not always a fix available, it should be kicked back to the developer to patch that before it even gets into the registry, and then from the registry, it should be not allowed to deploy if there's a patch available. But if it's discovered after it's run in production or there's no fix available, you know, what are you going to do? So you really need something like virtual patching to give you that protection.
Okay. We had a couple of questions related to other things that might do similar stuff, and recognizing that you know two of these might actually be your competitors. I still want to put the question out there.
Yeah.
Somebody, let's see, Narashima asks, how is NeuVector different from Aqua or Twistlock, and does NeuVector support container security?
Yeah, absolutely. So what Henrik talked about is an end-to-end container security platform. You know, of course, if you go to our websites, you'll see tons of overlap, and I must admit, we all start to look the same. The reason we started with the network segmentation part of PCI, and I spent some time on that demo, is we're really the only solution that does that layer 7 container firewall that's native to Kubernetes. And then it can run inline and block workloads and do all that packet capture stuff. So, you know, there are tools out there like network policy. You can try to do a little bit of that with Istio authentication, but that can get messy as well. But no one can really drop that in and automatically segment your workloads. So I would say that, you know, there's a lot of overlap, especially in the vulnerability management side. But really the runtime and the network side is really where we are unique.
Okay. I have three more questions, two of which overlap, so I'm just going to feed them to you as one. Dominic and Larry both, well, Dominic asked what kind of detection engines against threats do you use? And Larry said that he already has a lot of this functionality through mod security in his web application firewall, and he wants to know if you guys are using Spider Labs.
Right. So we're building our own detection into the enforcer pod that I showed there. So we're
Mhm.
not using, you know, like an open source for a WAF or anything like that. Also keep in mind that a WAF sits outside of your cluster, so it's going to be good to protect against a web application that's being exposed outside of the cluster. But also keep in mind that there could be insider attacks. You could have somebody get into your infrastructure and try a DDoS attack from within. Even a SQL injection attack can come from within. So think of us as doing some of those WAF protections, but mainly focusing on all of that east-west traffic, as well as making sure that there's no connections going from inside the cluster to external sources that are not allowed as well. And it's a multi-protocol firewall. So most WAFs are going to be limited to HTTP and certain threat vectors, but not things like DNS attacks or DNS tunnels, ICMP attacks, you know, other protocols that can be used to attack. And so the answer to the other question is we essentially build in our own attack detection. Some of it is pure looking at the network connection and analyzing the packets. Others of it, I'm trying to think of an example, like a reverse shell or a tunneling often combines a process that starts up to do that shell or open a tunnel, and that's
Mhm.
combined with a network tunnel that we detect. And by doing that kind of correlation, it's going to be more accurate detection.
Okay. There's a handful of other questions, but let's get back to, I know you have more stuff to show everybody, so we'll hold these until the end if you leave time.
Sounds good. Okay, so I'm going to show a demo of the vulnerability management side. For this demo, so first of all, as Henrik mentioned, there's a number of plugins that exist both for NeuVector and other scanning tools like Quay that you can trigger doing your Jenkins build or your other tool process, and those should be implemented. And then once the images get into the registry, that's what I'm going to show here. And I'm switching over to a different demo environment because this is where I've got a bunch of registries to be scanned configured. So this is a demo environment running on GKE. Mainly because you can see, you can use any registry to store your images, and also other scanners that may exist to scan those images. So Henrik mentioned that you can use NeuVector to scan your image, and then we will do what's called a layered scan. And that will show you, like, for example, out of 139 high vulnerabilities, 13 of those are found in this layer, and this is the build command used to build this layer. So it makes it easier to get back to the dev team if they need to remediate that. But if you're using a different scanner, such as JFrog X-Ray, we also have a number of integrations where you can configure that. And so you can either use these built-in integrations or a REST API to feed in vulnerability scanning results into NeuVector. And so here we're looking at the X-ray scan results. And you may be asking, well, why would you want to see that in NeuVector? A couple things. You can compare that with the runtime scans that I'll show in a minute. But actually, more importantly, is the link to admission control. And that's what Henrik talked about briefly. And that's admission control is really the bridge between your pipeline and your production environment. It's the last chance to block anything bad from going into your environment. And for this, we leverage the built-in admission control webhook that's built into Kubernetes. So anytime there's a deployment that's going to be tried, and in this case, there's a rule that says if there are 5 or more vulnerabilities, then block that deployment. Kubernetes will webhook to NeuVector and ask us if it's okay to deploy. So in this case, I'm going to deploy into the admission demo namespace another Node.js deployment with 3 replicas, and okay, so you can see that was blocked. And again, we need the forensics. We need to be able to report this and save it for inspection purposes and compliance purposes as well. So in my risk reports notifications, you could see here this event has been detected. And we even show that there's which rule fired that blocked this deployment. High count is greater than or equal to 5. Now, if that was allowed to deploy, then you would see a bunch of container scans. The runtime scanning would kick in, host scanning, all of the runtime scanning would kick in for any deployment that's allowed. Now, how do we make sense of all these vulnerabilities that we're seeing, hundreds of vulnerabilities? We can look here in the security risk tab, and the most interesting thing, in addition to being able to filter by those with a fix or without it, high, medium, namespace, and get your reporting for whatever area that you're interested in. One of the most interesting things is, let's take, for example, this high vulnerability right here. We're going to show you the hosts as well as the images and the running containers that this vulnerability was found in. And in this case, there are no hosts with this vulnerability, so we're showing that there are these 6 images where this vulnerability exists. And the reason for the red, green, and black is back to the concept of virtual patching. When it's green, it means that there is a container running that is protected, either in the monitor or protect mode. And if it's not protected, then it's shown in red or in black, in which case there's no container running. So I've got images here that have this vulnerability. You could see the containers running from those images. And you could see in this case, the ones in green are my Node.js pods because I had that in that protect mode that we saw earlier. So this is a way to understand the impact of this vulnerability on your runtime environment and understand which containers are virtually patched and which are vulnerable, so which need to have some type of protection turned on. All right, so I think that's it for the virtual patching demo. Now, Henrik, I believe I'm going to continue on here, right? As
If you don't
security
mind,
as
just
code?
yeah, exactly.
Okay,
That would be the last topic of this morning.
okay. Last topic for today is security as code. This is actually one of my favorite topics, one of the most exciting new things, I think, in security and Kubernetes, not just infrastructure as code but security as code as well. And I think I saw a question earlier about, building security in. And so everything we're talking about can be built into the pipeline and automated. And at the end, there is a guide you can download to talk about 10 steps to build in and integrate and automate all of these security steps. One of the most important parts of that is security as code. And it should not be a burden for the dev team or the DevOps team. And the way Kubernetes works and this thing called CRDs or custom resource definitions is a perfect implementation or perfect use for security as code. Now, if we take a step back, we know that Kubernetes is kind of a declarative-based system. Everything you declare in that YAML file represents the desired state. And you should change management, all those YAML files. You should have checkout procedures and updates and tests anytime there's a change to that desired state. Security should be done in the same way. Security should be declared as early in the pipeline as possible. In the past, the firewall people, way after workloads were deployed, went into their firewalls and tried to create firewall rules. And often that's a trial and error process. But with our modern pipelines, we can build that into the pipeline. Now, what are the challenges for security as code? First is, okay, what should we declare? What are the rules or what security concepts should be in our security as code? The second is, every small DevOps team wants to rapidly deploy as much as possible. How are we going to coordinate all that security code? And then all our services need to connect and communicate. It can be a dynamic environment. How do we make sure that we've accurately captured all that communication and network visibility? So I'm not going to get too much into why security as code because you're all, Kubernetes experts. But the reason you're using containers in Kubernetes is really to improve the speed, agility, and reliability of the pipeline. And security should be the same way. It should not stop or slow down your pipeline. And so CRDs need to be able to be created, tested, and developed in minutes, not days or months. And so, if you look forward past all the vulnerability management stuff we've been talking about, this is really could be one of the most important layers that you can automate and use to protect your workloads that you're going to run in Kubernetes. So what is a CRD? It's a custom resource. Kubernetes makes this available, and so we can use it to extend the capabilities of Kubernetes so that every time something is deployed, it's kind of like the admission control webhook. It lets NeuVector know that there's a new security rule coming in. And so there's two types of CRDs. Those are scoped at a namespace level, and those that are scoped at a cluster admin level. And so CRDs are enforced using the RBACs of Kubernetes. So that's a great thing, because RBACs are critical for making sure that somebody who can update a rule in a specific namespace using the security rule isn't going to clobber something in a different namespace. So at a high level, we're going to look at a YAML file, just like the deployment YAML files that we take a look at, but it's going to be a security rule YAML file. And that's going to refer to this CRD, the NeuVector security rule CRD definition. And all we have to do is apply that, just like we do to create a deployment. We apply this, and Kubernetes knows that it's going to deploy this set of rules. It lets NeuVector know that this is inbound, and NeuVector will take it from there and create these rules. So let me show you a quick demo of CRDs. So as you recall, in my demo environment, I had my three-tier application stack running. So I've got Nginx, which is talking to Node, which is talking to Redis, and I got to, how do I unselect my containers? I don't want all containers. I just want my demo stack. All right, and so, and you recall that as you run your test traffic through, we're going to record all the processes. We're going to learn the behavior of that application, and we're going to capture that in those rules that we took a look at in the console. But now what we're going to do is we're actually going to export that in the form of a YAML file, which is implemented to implement a NeuVector CRD. So if we take a look at that. So this is the format of a NeuVector CRD, and as we saw, the Nginx pod in the demo namespace can talk to the Node pod using this HTTP application protocol. And let's say that I'm going to allow SSL. I can simply edit this CRD and add that to it. We can see that when that application is deployed, when these rules are deployed, it's going to be deployed in the discover mode. But in my production environment, I do not want it in that learning mode. I want it in the protect mode, so I can simply change that. So the process that you might use for this is to use the learning in a test or staging environment, export that, and review it with the dev team to say, hey, does this describe accurately and completely the behavior of your application, the network connections, the processes being allowed in every pod? So here we've got, let's say curl. No, curl should not be allowed here. So, I was only using that to test out my application. So let me get rid of curl being allowed in that pod. Once this is signed off on by dev and DevOps, this can be saved as the security policy of record for that application stack, and it can be deployed into the production environment. And that way, before you deploy your workloads into the production environment, you have already set up the security policies for them. So just to show a demo of that, I've actually taken what we've exported there and I've put it into this file here. And all I've done in this file is I haven't changed anything actually. All I've done is I've changed the namespace into which this is going to be deployed. So instead of the demo namespace, this is going to be deployed into the admission demo namespace. So let's deploy that. Now, I'd say in your typical environment, I would not be deploying this back into my test or staging cluster. I would actually be deploying this into my production cluster, right? So it's a good tool for testing things as well as being able to migrate policies to production. Now, if any of these rules change, I would check out that YAML file, make the changes, test it in my test cluster, and then deploy it in my production cluster. So if I go back into here, I can get more of a visual view of how those CRDs look. Okay, I think I'm getting some lag in the network, in the refresh. So maybe I'll come back to that. So what I'm going to do is I'm going to switch over to this cluster where I do have some CRDs deployed that I can actually use to show you here. So for example, the Nginx pod, you can see here that, I gotta uncheck that other one. Okay, so you can see here for my Nginx pod that I've got a bunch of network rules and they're all been created by a CRD. You can see that there are process rules that are allowed and these have been created by a CRD. The reason the CRD designation is important here is that you cannot change these rules through this console. Whereas in a non-CRD environment, if I went to my SQL rules here, I could take a look at my process rules and I could select this one, I could edit or delete it. But if rules are created by a CRD, remember that YAML file is the security policy of record. It's the declarative state of these security rules. So if you want to change those, you need to check out that YAML file. You need to edit it, test it, and then put it through the pipeline just like you do normal code. Okay, so let's see. I think that's a quick demo on CRD. And Henrik, you want to summarize
Yeah,
what we covered today?
yeah, happy to wrap this up. That was a long but hopefully educational session here. We showed you how to build security into your pipeline from the beginning. Vulnerability scanning is table stakes, but it has to be implemented from the very beginning to the very end. As you've seen, the network security is a requirement for the PCI compliant environment. And as Glenn just showed you, security as code really enables collaboration between DevSec and Ops. And so that is that is a super exciting new thing that we're showing customers. There are a couple of pieces of collateral that you can download. So the PCI guide here, as well as the container security automation blog. So please, we'll send out the slides tomorrow, and you can also go to the website, NeuVector website, and check that out. With that, Adrian, let's take some more questions.
Oh, we've got questions. People are blowing up the questions chat. All
There
right,
we
so we've
go.
only got about 12 minutes left. I'll just start from the top. Larry says that he's heard from PCI auditors that Kubernetes should have layer 4 and not layer 7 protection. Do you guys have any comment about that?
Well, layer 7 protections are really a given accepted best practice. I mean, it's a, what's the other word for a layer 7 firewall? A stateful firewall. And so keep in mind that the protocol level protection that we're doing is verifying everything in the network section. You can think of it as a superset of layer 3, layer 4. But you can also define layer 3, layer 4 rules in NeuVector as well. And that's especially useful, as I talked about, for egress control, because if you have a pod connecting to a database on a VM or an API service, you may have to define that by an IP address or a port.
Okay. Narashima asks how well NeuVector scales for large clusters.
We can support up to the Kubernetes limits. I don't remember what the current limits are, 1,000 nodes or so. Remember that the enforcer, which is doing the network inspection, process inspection, all of that, is a daemon set. So it's one container on every host. And so it scales as you scale your hosts. And even if you've got auto scaling on, of course, Kubernetes will put one on there. If you have one of our customers is a large credit agency, and they're running on 64 and 128 core systems. And so, if you have huge traffic and number of pods, then you could use Kubernetes to dedicate a CPU core to the NeuVector enforcer.
Robbie asks an interesting question. So Robbie says, I understand from Amazon that the CIS benchmarks on the EKS control plane is part of shared responsibility and is part of the shared responsibility model, and it's invisible to customers. And he asks if there's a way for us to run CIS benchmarks using NeuVector against the EKS control plane.
Yeah, that's a good question. Currently, the CI's benchmarks, we can only access the worker nodes. So the masters are controlled by Amazon. But should they open that up, we'll be able to do that. I think GKE is actually, making those benchmarks more visible and accessible as well.
Okay. We have more questions from Ravi. We also have questions from Juan Manuel. Juan Manuel has two questions. One, during a PCI audit, what is this? It's funny, it's like Jeopardy. During a PCI audit, what's the strategy in front of the QSA to show CDE is well protected by network policies at the Kubernetes cluster level? This is a really long question. You can probably also see it in your question panel if you want to read it with me. He continues and says, on a traditional environment with firewalls and virtual machines, they will ask for evidence about network segmentation and also a full review of the firewall rules that apply to those network segments.
Yeah, that's a really good question. And so I bet the most PCI auditors are not able to read YAML files. So that's why it's good to have both. It's good to have the CRD, which represents all of your rules in a YAML file, or network policy, for example. But what they really are used to is what I showed, which is a typical firewall rule is from a source to a destination, enforcing a protocol and or port or other destination. And so you've got to be able to show those, export those and show those, which you can do. And you've got to then demonstrate, you got to show which ones of your workloads, like we saw, are in your CDE environment and how you're segmenting those rules so that no other connections can be done. And because this is a whitelist based approach and not a blacklist based approach, it's really demonstrating that those rules are working, and if there's an unauthorized connection, that it's either blocked or there's a violation picked up.
Okay. He has a follow-up question. Says, I'm also wondering how Kubernetes components and their internal connections can also be compliant with PCI DSS as part of the infrastructure.
Well, NeuVector is monitoring if the enforcer is installed on the master nodes where the API servers are running. We are monitoring all the network connections and processes in there as well. We are vulnerability scanning those if the enforcer is on those as well. So it meets most of those PCI requirements for the infrastructure itself. And the same would be true if you deployed a service mesh. We're also monitoring all the service mesh traffic and the service mesh control plane for not only vulnerabilities, but network traffic.
Okay, great answer. Robbie asks if there are any NeuVector Jenkins plugins available that they can hook into the pipeline to scan images during the CI phase before uploading them to Artifactory.
Sure, absolutely. Yeah, just in the plugin search in Jenkins, you can just search for the NeuVector plugin. If you're using other tools like Azure DevOps or Circle CI or any of those, there's also orbs and extensions for those as well.
Okay. Daksh asks, if the traffic is encrypted, does this solution still work? And by solution, he means detecting malicious activity in encrypted traffic.
Yeah, another great question. So, of course, just to recap, we are not a proxy or a termination point, an SSL termination point. We are more like a bump in the wire, like a true firewall. So we're not going to terminate that or try to break into that connection if it's encrypted. We will enforce if we detect there's an SSL connection or TLS connection between pods or to an external connection, we will enforce that only that is allowed. Now, if you're using like an Istio service mesh and you've turned on pod-to-pod encryption, in that case, we can inspect all of the traffic before the sidecar proxy encrypts or decrypts the traffic. So in that pod, there'll be your application workload and it's going to connect to the sidecar. We're going to intercept the network traffic there before it gets encrypted or decrypted. And so we can apply all of the segmentation, the packet inspection, and the threat detection.
Very comprehensive. We have two more questions. One more from Ravi, who promises this will be the last question from Ravi. But it's fine, Ravi. If you have more questions, feel free to ask. One more question. How different is the NeuVector runtime image scanning? Wait, how different is the NeuVector runtime image scanning? Okay, I'm going to phrase this differently, so it's a little more succinct. How is the NeuVector runtime image scanning different from Docker Content Trust with Notary?
The runtime image scanning is actually looking for vulnerabilities of in the image itself or in the container that's running in the running container environment. So Content Trust is more looking for to verify that indeed it's the original container. It hasn't been, or the image hasn't been modified before you deploy it. So they're a little bit different topics. I'd say that can be used more in the admission control side rather than the runtime scanning side.
Okay. Binu just popped up with a question asking, how do you inject in through the layer between the container and the Istio sidecar? Is it another sidecar?
No, that's another good question. So it's just the same enforcer that we talked about. It's a container that runs on the host itself, and
Okay.
we are able to inject. I mean, essentially, it's not quite technically accurate, but you can think of us as listening on the virtual bridge, the Linux network bridge, and so we can see all the traffic on that host, including sidecar to workload traffic. We have the ability to know that it's in a specific pod, what that workload is called, what service it belongs to. We can correlate all that once we can see all that traffic.
Okay. John asked a question a while ago. He says, you always get false positives with scanning, so the routine of allowing a certain image with CVEs is super important. He asks
Yeah.
if you can describe that a bit.
Right, so you can set up certain policies. The most obvious one would be if there is a fix available or if there's no fix available. So we'll scan the image, and if there's a fix available, we can kick it back. And of course, you can add additional criteria like the severity of the CVE, or if it's running in container, or if it's a base image, or things like that. It's true that vulnerability scanning is a little bit of an art, and if you used 5 of the different scanners that Henrik mentioned, you might get slightly different results because of the way we all interpret the CVE databases that we have access to. Also, to understand whether or not that vulnerability really does exist in an image or can be visible once it's containerized.
Okay. Abid says, so earlier we asked a question about Twistlock and Aqua, and you mentioned Claire in your presentation. And Abid asks, what would you say is the major difference or improvement or plus point or something that you have over a solution like Claire?
Oh, that's there's a number of different dimensions of that. That, of course, the first would be the vulnerability scanning itself. We not only tap into the same MITRE and other databases that Claire has, but we also scan all the popular Docker software, Node.js, Java, Python, all of those, and can do the dependency analysis as well. So there's scanning differences. There's also display differences, like the impact that we show on running containers. And there's also scalability and performance considerations. I mean, we have some customers that will scan, if there's a CVE database update, they'll need to rescan their entire registry and set of repositories enterprise-wide, and that could be 100,000 images. And some scanners have just not completed the job. Whereas we just released where you can have parallel scanner pods, and so you can scale that up and have multiple scanners running in parallel if you have a big job like that to do.
That's nice. That's it for the questions, and that's also it for the time. But I wanted to just close out and ask if people wanted to follow up with you guys for more information about NeuVector, what's the best way that they can do that?
Our website is the best way, info or contact, info@neuvector.com, or there's a contact form as well. And then yeah, we would all of our images are in a private Docker Hub registry, so we'd whitelist you and then give you access to those. And then if you'd like, we will actually walk you through the deployment, even though you can deploy it easily through the Rancher catalog or through Helm or kubectl commands. It should be pretty simple for an advanced user.
Fantastic. All right, well, I want to thank both of you, Glenn and Henry, for the presentation. I hope that everybody who was able to join us today, I see that you guys are starting to drop off because we're now over the 90-minute mark, but thanks to all of you who stayed. And remember that this was recorded. You will be getting an email in a day or so that has a link to the YouTube video and a link to where you can get the slides. And yeah, that's basically it. We're out of time, so I'm going to wrap it up. Thank you for coming.
Thanks, Adrian.
We will
Thanks,
see you all
everyone,
again
for
soon.
joining. Thanks, Henrik.